Hello students, we are going to study chemical properties of metals. Actually when we are seeing chemical properties, it means what? Here, how does the metal react with different substances like oxygen, water, acid, base, how they show the properties, okay? So here, first we will be studying what? Reaction with air. So when we are saying reaction with air, okay, so we will be studying what? Reaction with oxygen. Have you seen the metallic substances like aluminum vessels and all, or any other also? When you see it, it is too shiny in nature. You just keep it in the air, okay? You buy from the market, bring it home, keep it in the air for many days, okay? What you will see? That the luster has gone. It is not so shiny as you have brought from the market. Actually what happens here, this metal reacts with the oxygen of the air, and what it forms? Metal oxide. As the result, whenever a metal substances are left as it is in the air, what happens? This oxide layer gets on it, on the outer surface, because of the reaction of the metal with the oxygen of the air, okay? And as the result, we can't see that it is so shiny or so lustrous as we have brought it, okay? So let us see some reactions, okay? All the metals react with oxygen to form what? Metal oxide, okay? All the metals, they will react with what? Oxygen to form metal oxide. But one thing I'll say to you all, this all reactivity which we are seeing, the chemical reactivity, they are having what? They are different. Like if I say sodium reacting with oxygen and then I say gold reacting with oxygen, does gold react with oxygen? No, it is inert in nature, na? But sodium, when we say violent reaction is there, aluminum also reacts with oxygen, but the difference is there in the reaction rate, I'll say. Okay, like potassium, it will react very violently with the oxygen to form sodium oxide. Okay, but when we talk about aluminum, it will react slowly. Okay, so first, before starting this, I think so, this chemical properties of metal, you should know the reactivity series of the metals. Okay, you can see potassium, and then comes the sodium, and then calcium, and then magnesium, aluminum, zinc, iron, okay, tin, lead, okay, hydrogen I have written over here, I'll tell you why I have written, and then comes copper, mercury, silver, and gold. Okay, gold is very inert in nature. As the result, when it doesn't react with air so easily, and it, I'll say, negligible reaction we see with this gold. Okay, so here actually why hydrogen is written over here, because all these metals, okay, they react with the acids to give what? Hydrogen. Okay, so but this which is below hydrogen, they don't give. Okay, so reactivity decreases by the series in this manner from potassium to gold. Okay, so now this metal reacts with this oxygen. Okay, like sodium reacts with oxygen. Sodium is a very reactive metal. Naturally it will react with oxygen, okay, and it will give what? Sodium oxide will be formed. This reaction is very vigorous, okay, and very violent. So sodium is never kept as it is in the atmosphere, okay, because if it is kept, it is too reactive in nature and it will react with what? Oxygen present in the air. So it is always kept in what? Kerosene oil or any oil, so that it doesn't come in contact with the oxygen easily and it forms a sodium oxide, because this reaction will be very violent and vigorous. Okay, now, and if it is kept also, it is kept away from the contact of air. Okay, now magnesium reacts with oxygen. Okay, magnesium, you can see that, take the magnesium wire, okay, and magnesium wire, when you burn it, okay, actually first you have to rub the magnesium wire. Why ribbon? They will say, why we are doing that? Because oxide layer comes over it because of the presence of oxygen. But yes, this magnesium, slowly and slowly it reacts with water, oxygen present in the air and form magnesium oxide. Okay, if we heat it a bit, what happen? Combustion will take place, and naturally this magnesium burns with what? A dazzling flame in the presence of oxygen in the air to give what? Magnesium oxide. Okay, iron doesn't react so easily with the oxygen. Okay, you can see also it comes very low in the reactivity series. Naturally sometimes it happens of its own when temperature is high, otherwise if slow heating is done, slow temperature is applied, naturally it forms what? Iron oxide. Okay, so when we are seeing this, that yes, these metals are reacting with oxygen and they are giving what? The corresponding oxides. Okay, so what about the characteristics of these metal oxides? Actually these metal oxides, when we are seeing like sodium oxide, magnesium oxide, iron oxide, okay, some of them they dissolve in water, okay, to form corresponding hydroxide. Okay, and those type of metals are what? Called alkalis, because all the metallic oxides which you are saying, they are basic in nature. Okay, but some which dissolve in water, okay, they are known as alkalis. Like when we see sodium, sodium dissolves in water to form what? Sodium hydroxide. Potassium oxide also reacts with water to form what? Potassium hydroxide. Okay, so in this also we are seeing what? When they are dissolving in water, we are saying that this is an what? Alkali. Okay, so here, but maximum of the metal oxides doesn't dissolve in water, and so they will be called what? Bases only, not alkalis. But yes, these bases like sodium oxide, potassium oxide, calcium oxide, they all dissolve in water, and naturally they are now called as what? Alkalis. So what are alkalis? Alkalis are those metallic oxides, okay, which dissolves in water, okay, to form corresponding hydroxide. Okay, they are known as alkalis, and those which doesn't dissolve in water are bases. Okay, but one thing you remember, all alkalis are bases, but all bases are not alkalis, because all the bases do not dissolve in water. Only few dissolve in water, and those are known as alkalis. Now we have studied about what are alkalis, isn't it? Now we are going to the next property of these metallic oxides. They are basic in nature or they are amphoteric in nature. So what is basic in nature? Naturally, basic in nature, when we are saying like magnesium oxide, okay, it is basic in nature. Sodium oxide, potassium oxide, they are also basic in nature, but they dissolve in water to form the corresponding hydroxides. So we are saying them alkalis, isn't it? So metal oxides are what? Basic in nature. So I have taken an example of magnesium oxide. What happens when a base reacts with an acid? Neutralization reaction takes place. We have studied in acid, bases and salts, and their corresponding what they are formed. The salts are formed, and you get what? Water. So here also neutralization reaction can take place when we are taking what? Metallic oxides. They are basic in nature. They react with the acid to form the salt and water. So we are getting what? In this we are getting this magnesium oxide. It reacts with what? H2SO4 to form what? Magnesium sulfate plus what? Water. Okay, but there are some other metallic oxides also which are what? Basic as well as acidic in nature. How can we say? Actually what happens when an acid reacts with an base, neutralization reacts takes place to form what? Salt and water, isn't it? Naturally if we are taking any basic salt, okay, or basic oxide, sorry, and we are reacting with acid, okay, it will give salt and water, isn't it? And if we are taking any acidic salt reacting with water base, we will be getting what? Salt and water. So when we are seeing with these two oxide, aluminum oxide, zinc oxide, okay, they are amphoteric in nature. They can react as acids also as well as bases also. They have the behavior of acidic behavior also and basic behavior also. How? See, we are taking what? Aluminium oxide, and we are reacting it with what? Hydrochloric acid. Naturally what will happen? This is a acid. Okay, aluminium oxide is reacting. Here it is acting as a what? Base. Okay, and what happened? We get aluminium chloride and we get what? Water. Okay, when now aluminium oxide, okay, is reacting with NaOH. So here aluminium oxide is acting as what? An acid. So it is reacting with a base to form salt and water. Which salt it has been formed? Sodium aluminate, that is NaAlO2. Okay, now like zinc oxide. Okay, here it is reacting with HCl. HCl is an acid. So here zinc oxide is acting as a base. So naturally what we are getting? Salt and water, that is zinc chloride plus water. Now when zinc oxide is reacting with this NaOH, that is a base, isn't it, NaOH? So here it will act as, zinc oxide will act as a acid, and it will form what? Sodium zincate, Na2ZnO2 plus water. So we are seeing this oxides of metal, they are mainly basic in nature. I am saying mainly means majority are basic in nature, but yes, some are also amphoteric in nature, which acts as acids as well as base. They have that behavior and they are called as what? Amphoteric oxide, and the best examples are aluminium oxide and zinc oxide. Now we will be studying reactions of metals with water. Okay, so here first thing you must remember, whether it is air, whether it is water, whether it is anything, the reactivity is according to the reactivity series. Okay, which will be more reactive? Potassium, and then sodium, then calcium, then magnesium, then aluminium, zinc, iron, tin, lead. Okay, and hydrogen. I said only these elements can what? Displace hydrogen, isn't it? Rest these can't give out what? Hydrogen. This copper, silver, mercury, gold, they can't. Okay, so now what happens when there is reaction of metals with water? Actually they react in a different manner, with cold water, with normal water, with hot water, and with steam. Okay, we will be studying it. As soon as I say cold water, you will understand that yes, the most reactive elements will react with what? The cold water, isn't it? So the most reactive elements are what? Potassium, sodium and all, isn't it? So potassium and sodium, they will react with cold water, okay, to give what? The corresponding hydroxide. Like here sodium has reacted with water to give sodium hydroxide, okay, and what has been evolved? Hydrogen has been evolved, because whenever a metal reacts with water, it forms with water, with which water? Cold water. Okay, it gives what? Metal hydroxide and hydrogen gases given out. Okay, now let's see with what happens with the case of calcium. Calcium with cold water not, but it reacts with warm water. Okay, in the presence of warm water, this calcium gives what? Calcium hydroxide and hydrogen gases given out. Okay, magnesium, when we come to magnesium, magnesium reacts with hot water, okay, to give the corresponding magnesium hydroxide, and hydrogen is given out. Okay, but what happens with the steam? When a metal reacts with steam, it forms what? Metal oxide and hydrogen is given out. So magnesium, when it reacts with warm water, it gives magnesium hydroxide and hydrogen is given out. But when magnesium reacts with steam, okay, it means water in the gaseous form. Okay, what happens? It gives magnesium oxide plus what? Hydrogen gas is given out. Okay, likewise we can see with aluminium, zinc, iron also. Okay, then comes aluminium. Aluminium also reacts with steam to give aluminium oxide and hydrogen gases given out. Like that, coming to zinc, zinc also reacts with steam to form what? Zinc oxide and hydrogen is given out. Iron also, by reacting with steam, it gives what? Iron oxide and hydrogen gas is given out. But when we come to copper, copper, does it give hydrogen gas and the corresponding oxide? No. Okay. On prolonged heating also with the steam, the reaction doesn't take place in case of copper, and it does not displace to give what? Hydrogen gas. So we have studied about the reaction with water, different types, cold, hot and with steam. All we are seeing according to the reactivity of the metal, isn't it? The reaction which had taken place in case of water was what? Displacement reaction, we can say, redox reaction, and as heat was also evolved, so they are also known as what? Exothermic reaction. In this case also we will be studying with the reaction with dilute acids, okay, the metals, okay. Here also we will be seeing all the reactions can be said to be a displacement reaction, a redox reaction or exothermic reaction, okay. For example, I will be explaining you right now. We have taken zinc. Zinc, when it reacts with dilute HCl, what happens? It forms what? Zinc chloride plus hydrogen gas is given out, okay. When we say about magnesium, it also reacts more vigorously than zinc to form magnesium chloride and hydrogen gas is given out. When we talk about this sodium, this reaction is violent, okay, tremendous amount of heat is given out and it is so vigorous, okay. It reacts with this dilute HCl to form what? NaCl plus hydrogen is given out, isn't it? When we are seeing all these reaction like zinc, magnesium, sodium with the dilute acid, okay, the reaction, the rate of the reaction, the vigorous, the more reactive the element of the metal, the more vigorous the reaction will be and more exothermic it will be, okay. When I am saying only three metals, okay, I will be taking over here, zinc, magnesium and sodium, which will be more reactive? Sodium, isn't it? And then comes what? Magnesium, and then comes what? Zinc. Likewise, if aluminum is also given, you can see the reactivity series. Accordingly you can write that how vigorous the reaction will be with the dilute acids, okay. So when we are seeing with dilute acids the reaction, all will be giving the reaction, but will gold, silver will give the reaction so easily? Okay, like gold, it will not give the reaction, okay. We will be studying how it is giving, okay, later on with aquaresia, okay. So here I have written the reaction with HCl. If you write with, instead of HCl, if we write over here what? H2SO4, okay. So what will be formed? ZnSO4, isn't it? Plus what it will be formed? Plus H2 will be given out, okay. So with dilute sulfuric acid also they will react, but to give the corresponding salts, like when zinc reacts with H2SO4 dilute, it gives zinc sulfate and hydrogen gas is given out. Like magnesium reacts with sulfuric acid H2SO4 to give what? Magnesium sulfate and hydrogen gas will be given out. Like that, sodium also reacts with dilute sulfuric acid to give what? Sodium sulfate and hydrogen gas will be given out. But we can't use nitric acid, okay, here. Why? Because when zinc will react with dilute nitric acid, okay, corresponding zinc nitrate we will be getting, but we will be getting what? A nascent oxygen. That nascent oxygen, okay, will combine with the hydrogen which is giving out, okay, and it will oxidize that hydrogen to form water, and so the reaction with dilute nitric acid is not possible. But it is possible with two metals, that is the magnesium and the manganese. They both, we see that they give the corresponding nitrates when they react with dilute nitric acid. Like magnesium, when it reacts with dilute nitric acid, it gives magnesium nitrate and hydrogen gas is given out. Manganese, when it reacts with dilute nitric acid, it gives what? Manganese nitrate and hydrogen is given out. Only these two metals, rest they don't give, because what happens in the reaction we get nascent oxygen which acts as an oxidizing agent, and it oxidizes hydrogen to form water, okay. So we have studied that gold and platinum doesn't dissolve in these acids like sulfuric acid and hydrochloric acid, nitric acid, okay. They dissolve in what? Aquaresia. So what is this aquaresia? Actually, in this freshly prepared solution is made of what? Concentrated hydrochloric acid and concentrated nitric acid. Okay, concentrated HCl 3:1 we are taking. HCl is in 3 parts and HNO3 in 1 part. Okay, and we make a solution. Okay, and when the solution is made, we are seeing HCl plus HNO3, it gives NOCl. NOCl is nitrosyl chloride, okay, plus water and plus nascent chlorine is given out. Okay, you can see 2 atoms of chlorine I have written over there, isn't it? So it is nascent chlorine, and this nascent chlorine is only responsible for dissolving what? This gold and platinum, and with this nascent chlorine only this gold and platinum reacts. Okay, so gold reacts with this water 3 Cl or 2 Cl, which whatever it has been produced to give what? Gold chloride, and platinum reacts with chlorine to form platinum chloride. Here 3 Cl is taken, you are getting what? Gold trichloride. Here you are getting what? Platinum tetrachloride. Okay, so in this manner we see that gold and platinum dissolves in aquaresia only, and aquaresia is nothing but solution made from concentrated HCl and concentrated HNO3 in the ratio 3:1. And what is responsible, okay, for the reaction? That is the chlorine atoms which are present after the reaction with hydrochloric acid and nitric acid. So this is the manner the metals reacts with the acids. You can see, you can compare with the reactivity chart. Okay, according to the reactivity chart only you will be writing the reaction. It will be easy for you all, otherwise it will become difficult. And if you learn from the reactivity chart what it is being produced, it becomes easy. Now, how do they react with halogens? Okay, how do these metals react with halogens? What are halogens actually? Actually, halogens, we can say fluorine, chlorine, bromine and iodine. Collectively you will say what? Halogens. Actually it is placed in the group 17 of periodic table. Okay, so now these metals either reacts directly with this halogens to form the product, or what happens, we supply some heat to it and it forms the corresponding salt. Okay, so here you can see NaCl reacts with chlorine. Okay, no need to heat. Okay, very reactive in nature. So you will get what? NaCl. Magnesium also no need to heat, it reacts to form magnesium chloride. Okay, but zinc and copper, you are seeing over here, these 2 examples as I have taken, it reacts with chlorine but on heating to form water, zinc chloride. Okay, now here copper also reacts with this chlorine to form what? By heating zinc, this copper chloride. Okay, so in this manner we are seeing if some we need to supply heat. Why? Because they are not so reactive in nature. One thing you must remember, in normal conditions if anything is reacting, it means it is too reactive in nature. But if we are supplying some heat or anything, it means they are not so reactive as the reactive elements. Okay, now this metals are good reducing agents. Okay, you have I have explained in the first chapter also how the oxidation and reduction in terms of electrons. Here also I am saying in that manner. Okay, actually they are good reducing agents. Why we are saying they are good reducing agents? Because they can give out their electrons easily. Why they give out the electrons easily? Because in the valence shell, in the outermost shell, okay, few electrons are only present, and we all know in the outermost shell there must be 8 electrons. If we are talking about sodium, sodium has got only 1 electron in the valence shell. Naturally it will try to give and become stable. So here I have taken the example of NaCl to show you the reducing property. Okay, here sodium can give easily 1 electron to this chlorine. Okay, so if it is giving 1 electron, naturally it is being oxidized, isn't it? And chlorine is taking the electron, so it is being reduced. So we say that yes, this sodium is a good reducing agent, because with which it reacts, it reduces it, but itself gets what? Oxidized. Now, reaction with hydrogen. How do metals react with hydrogen? Metals have a property to give the electrons. Okay, hydrogen also has got that property. It also gives the electrons to become stable. But here what happens? Some reactive, very reactive I'll say, metals reacts with hydrogen to form compounds. In this, the metal gives the electrons to hydrogen, hydrogen accept the electrons, okay, and thereby forming what? Ionic bond. Okay, so here we'll be seeing this happens only in case of very reactive metals, okay, and naturally when they react with this hydrogen, they form the corresponding hydrides. Like sodium reacts with hydrogen, reaction is very vigorous, very violent, okay, tremendous amount of heat is also evolved. Okay, so here sodium reacts with hydrogen to form what? Sodium hydride. Okay, and this sodium hydride, when you react it with water, you will get what? Sodium hydroxide, and hydrogen will be given out. Okay, likewise calcium also reacts with this hydrogen by giving the electrons to hydrogen. Okay, and naturally it forms what? Calcium hydride, and when it reacts with water, it forms calcium hydroxide, and hydrogen is given out. So in this reaction with hydrogen, only limited elements, the most reactive elements will say, are participating in formation of the corresponding hydrides. Now next, reaction of metals with salt solution. Like we have taken the metal zinc, okay, salt solution we have taken of iron sulfate. Okay, we are seeing what? It is becoming zinc sulfate and iron is given out, or we can say that we get it as residue. Okay, actually what happens in this metal reacts with salt solution. Okay, it displaces actually the less reactive element. Zinc is more reactive, iron is less reactive. Naturally it displaces iron from the salt solution and itself becomes the salt, and iron is given out, okay, or displaced I will say. Here also we can see silver nitrate. Silver is less reactive, we can see in the reactivity series, less reactive than copper. Naturally copper displaces this silver, okay, and forms copper nitrate, and silver is displaced out, isn't it? Because these we are seeing iron is less reactive than zinc and silver is less reactive than copper. Naturally what happens? Metals react with the salt solution, okay, to give the corresponding product. Now reaction with strong alkalis. Some elements, some metals reacts with strong alkalis. Like strong alkali, when I am saying, like what? NaOH is a strong alkali, isn't it? You all know. Here metals like zinc, I have given you the example. Zinc reacts with this sodium hydroxide to give what? Sodium zincate, isn't it? And hydrogen is given out. And aluminium reacts with the sodium hydroxide to give sodium aluminate, okay, and hydrogen is given out. It means these we are seeing zinc and aluminium, they are displacing, okay, what? Hydrogen from the solution of the alkali. Okay, so one more point we can say about the metals, that metals are electropositive in nature. Why they are electropositive in nature? Because they give out electrons. Naturally if it is giving the negative electrons out, it becomes positive, so they are electropositive in nature. When I am talking about the reactivity series, and I am talking about what? The most reactive, and then going down it is decreasing. Why this has happened? Why they say that this metal is more reactive than the other element? Actually we see it. How we see it? We see what is the tendency of giving the electrons of the metal. If it can give out the electrons easily and very fastly, they are more reactive. If they can't, they are less reactive. And by that comparative study only we take out the reactivity series. Okay, so this is all about the chemical properties of metals. Good day, take care.